Hello everyone. So as we are studying statistical measures, in statistical measures there are two things. First is measures of central tendency and second is measures of dispersion. So in measures of dispersion I taught in last session standard deviation. Now we will see mean deviation, or we can say mean absolute deviation also. So we are studying statistical measures, two parts, measures of central tendency and second is dispersion. In dispersion, in last lecture I taught this standard deviation. Now we will see this mean deviation. So as standard deviation is based on mean, in standard deviation we will find x minus x bar. So a standard deviation is totally based on arithmetic mean. But mean deviation is based on three things. First is mean, second may be on median, third may be on mode. So first we will see formula of mean deviation. So mean deviation we will learn with this concept of average age. So average age formula or mean age formula is sum of ages divided by number of observations. So if in this formula we replace this word age by deviation and this word ages by deviations, so we will see this become mean deviation and this is sum of deviation. So this formula of mean deviation is what? Sum of deviation divided by number of observations. So now this sum of deviations may be about mean, may be about median, may be about mode. So first we are seeing about mean, and for this individual type of data set, and we need to find mean deviation about mean. So first task, we have this individual data. For this individual data, first we will find arithmetic mean. Arithmetic mean by using x bar equals to summation x divided by n. So summation x in this case is 63 divided by 6, then you will get x bar is equal to 10.5. This is first task. Now this is the concept sum of deviation. So first we will find sum of deviation. In this case we are finding mean deviation about mean. So we will find deviation about mean. So this is 17 and mean is what? Mean is 10.5. So from this 17 we will subtract 10.5, then you will get 6.5. From this 13 you will subtract 10.5, then you will get 2.5. Now we will take its modulus. To convert all negative and positive values, we will convert into modulus value. So all these modulus values are positive, then we will find summation. So this summation is known as sum of deviation. This is known as sum of deviation. So for this sum of deviation, we can put sum of deviation. Sum of deviation is what? Summation of modulus of x minus mean, or we can say x minus x bar, and this divided by number of observation n. So we can say this is what? This is mean deviation about mean, because we are finding with respect to mean, and this is what? This is denoted by mdx bar. This is mean deviation about mean. Now to find its coefficient. To find its coefficient, formula is coefficient of mean deviation about x bar. This mean deviation about x bar about mean. So in this case we will divide this mean deviation x bar by x bar. So now you can find its coefficient. Now we will see this example of individual data set. So in this is the formula of mean deviation, just I have written. So in this case summation of this column is this, 19, sum of deviation, this is 19, and number of observations are 6, then mean deviation equals to 3.166, and its coefficient. Now to find coefficient, this same quantity, this mean deviation about mean, this 3.166 divided by arithmetic mean. Arithmetic mean is what? 10.5. Then your answer for this coefficient is 0.3015. So this is what? This is mean deviation about mean when we are taking deviation from mean. Now in that way, we will see other formulae for mean deviation about median and others. So this is the main formula of mean deviation about mean for individual data when we have only X in data, and this is coefficient of mean deviation. Now to find mean deviation about mean for this individual data, simply we will replace this mean by median. So first task is what? First task, calculation of median. And then after finding this mean deviation about median, we will divide this quantity by median, then you will get coefficient of mean deviation about median. Just like in previous one, this mean deviation about mean is divided by mean, then this mean deviation about median is divided by median. Now we will see another one for individual data, that is mean deviation about mode. As per this concept, formula is this, but one important thing, in individual data there is no mode. That's why this formula is not applicable. This means we can't find mean deviation about mean deviation about mode, can't find. Is it clear? Because there is no mode in individual data. So now we will see example of this mean deviation about median for individual type of data. So this is the formula for mean deviation about median, and we have X, and first task is what? Calculation of median. So I have calculated this median. I will share link of median lecture in description. So in this case, median is what? 10. So for this 10, we will find X minus median. Yani X is equal to 6, 6 minus 10 is equal to minus 4, and 7 minus 10 is equal to minus 3. Then we will find its modulus. This means all negative values converted into positive, and then summation. So summation of this is again what? 19. In this case, this is 19, and this divided by number of observations, that is what? That is 6. Then again your answer is 19 upon 6. That is what? 3.166. Now to find its coefficient, this quantity divided by median. So this is 3.166, and median equals to what? Median for this data is 10. So you will see this equals to 0.316. So this is mean deviation about median, and this is individual data. So we can't find mean deviation about mode. So I hope you understand this concept. So please like my video and subscribe my channel. And in next lecture, we will see mean deviation about mean median mode for discrete data. Have a nice day. Thank you.